All right, happy and satisfied. Let's start this. So to talk about why Flutter exists, we need to talk about the motivations for Flutter. So, well, I guess that's the same thing, right? So there's a traditional thing that happened in the open source community where we wandered away from vendor lock-in. And some of us are old enough to remember ancient operating systems. Just a few of us, but yeah. Okay? And these operating systems were provided by the vendors specific to their hardware, and generally closed source with a few exceptions. And then came along the FLOSS revolution, the BSDs, the Linuxes, and others, which opened up a number of possibilities. The customers could fix it, extend it, modify it, or port it to new hardware and share their code freely with others. But more importantly, write once for Linux run on extremely varied hardware, from single board microcomputer devices all the way up to supercomputers. So Linux became the open source API for cross-platform compatibilities. We've had a parallel evolution in the mobile story. So for a decade, the smartphone vendors have been like the early computer vendors. Phone apps had to be written with vendor-supplied tool chains that varied between platforms. Vendor-chosen languages varied between platforms. More variety now than before, but it's still pretty primitive. APIs that varied greatly, even from release to release. And vendor-developed closed-source widgets and gestures and APIs and everything all the way up and down. So, traditionally, releasing for both iOS and Android required special skills or special teams, and never quite looked or acted the same on both platforms. But along comes Flutter and the game changes. So Flutter is a mobile app SDK, complete with a framework, with an engine, with widgets and tools. It gives mobile developers easy and productive way to build and deploy beautiful apps. It's currently in a preview release, not quite final yet, but really close. They're not changing any more of the APIs, or just fixing bugs. It's also used for Fuchsia. There's not much known about that yet, but it's imagined that it will be Google's solution to operating systems for the Internet of Things, like maybe their Google at Home product, things like that. Some people are also working on desktop apps similar to the way Electron works. That's not supported by Google, but people are doing it, and it's really looking interesting. Of course, the interesting part about Dart is that it can be used to build web and server applications as well, which means you learn Dart once, you can develop for 5 platforms. The exact same modern language. So what does Flutter do? It allows users to experience beautiful app UIs come to life. For developers, it gives them a way to build mobile apps. It speeds up the development cycle. You'll see this during the demo, how quickly you can actually modify a design. It also reduces the cost and complexity of app production across platforms. You don't need a separate iOS and Android team. And it permits a single mobile app team, for both iOS and Android. For designers, it gives high quality, original design vision without compromises that looks the same on both platforms. Great for branding and things. It's also a productive prototyping tool. Again, you'll see this during the demo. So what do you need? Well, Flutter uses Dart as the primary language. It's a modern, strongly typed language with familiar constructs. As you'll see in the demo, it's really pretty familiar. If you know Java or C# or anything in that genre, you're going to be completely compatible with it. Classes, methods, libraries, complex data structures, generics, strong type inference, so you can really make sure that your tooling is correct. imperative loops, of course, functional programming, streams and immutable objects. You need no prior mobile experience necessary. I'm even looking at building mobile apps now, and you know me as a Perl programmer, right? This is already empowering me to build mobile apps. I have a bunch of ideas right now, and I want to start working on them. I've already started working on them, I should say. And even people with very little programming experience seem to be productive rapidly. They were looking at doing some of the demos in the actual Google office, and the designers would sit down with the programmers, and after about a day or two, the designers would just go, no, I want to change that from red to green, and they'd know right where to do it. So this is already a big change in the design cycle. What can we build with Flutter? It's specifically optimized by design for 2D mobile apps that want to run both iOS and Android. Capable of brand-first design. In other words, you can make pixel for pixel the exact same application on both iOS and Android. You don't have to worry about how do I convert this to an iOS widget versus an Android widget. You don't have to think about any of that. You can make exactly the brand you want on all platforms. But it will also mimic the stock platform look and feel. For example, material design, Google's big contribution to well-designed systems, is a first-class citizen of Flutter. In other words, the material team works very closely with the Flutter team to make sure that it's always up to date every time material gets released. Full-featured apps, including native services. You can talk to the camera, you can talk to geolocation, obviously talk to the network, talk to storage. There are a bunch of third-party SDKs, and even more. For those of you familiar with Perl, there's the equivalent of the CPAN already. It's called the pub. And so there are already thousands of packages in there. So who makes and uses it? Well, it's an open source project. It's actually hosted on GitHub, so you can actually track it and things like that. It's originally developed and still heavily supported by Google as their replacement for Android, but that's another story. We'll get to that in a second. There are community contributions as well. And Google, of course, uses Flutter to build business-critical apps for iOS and Android. So they're already committed internally to this. For example, their mobile sales tool internally is done with Flutter. The store manager for Google Shopping Express, and a growing number of other internal projects. There are hundreds of apps already deployed by third parties in both stores, both the iOS and Android store. In fact, if you're familiar with the musical Hamilton, even though most of you probably haven't seen it, the official app for that was done in 3 months from concept to in the store on both platforms using Flutter from scratch. Is it production ready? Again, we're still in early preview. The APIs won't change, but there's probably some bugs that still need to be worked out. And Dart 2 is also getting rolled out soon as well. And from what I understand, they're kind of lockstep. They're not going to release 2.0 of Dart until 1.0 of Flutter is ready and vice versa. So they're both coming out lockstep. Again, API stable, some might still change. Well, it's less likely now. The preview release is pretty much frozen the APIs. Again, used extensively within Google. There are some key features like accessibility that are still being developed for deployment. It's a little further along than this slide has right now. But accessibility is obviously very important for international audiences. And what's great is Google is tracking the GitHub issues. That's how you communicate with them. You say, I have this issue, and that way everybody can sign in on it and vote on it and everything. So Google is really committed to doing this completely in the public. You can even submit a pull request. That's happened from time to time. Somebody fixes a bug somewhere in Flutter, or in Dart and submits a pull request. It's used by it's used by Google, a lot of other companies, a lot of developers around the world. I don't know what all these are. Last time I gave this talk, I had Wim Liller with me, who was actually the chief Google advocate for Flutter. So he was answering what all these icons are, and he gave me all the icons. So let's talk about what Flutter is, and why is it different from something like React Native? Classically, to develop a mobile app, you had to use native code in whatever language was provided by the vendor. You talk to, we call these OEM widgets, that's the widgets provided by Apple or the Android system. And that would eventually talk to Canvas and events. And then you also had to get sensation information so that you took that from the other side, location, audio, camera, things like that. But in order to do this, you had to write two different green boxes. You had to write one for iOS and one for Android. Okay? So along came the first solution to being able to be cross-platform. You'd write your app in JavaScript. Did I just say it out loud? Okay, sorry. Yes, you write your app in JavaScript. You had to use some sort of bridge to talk to all the services. And then you had to use a web view, which has its own trouble, to talk to Canvas and events. Okay, so this wasn't bad. It got us into portable, but it still had the downside of being slow because it's going through these bridges and it's going through WebView. One of the reasons that Google created Flutter, although I think I'm getting ahead of myself, is that WebView is not the fastest thing in the world. Okay? Because the DOM manipulations over time have gotten more complex and more complex and more complex. And in order to be fully compliant with a web view, you have to support all those different things about how to lay out a page. There's just way too much going on these days. So in a better cross-platform solution, still use JavaScript, but use a bridge now to cross both over to the OEM widgets. So now you're back to using a native pop-up button or a native slider or whatever. And that still talks to Canvas and events. So it's only slightly different from the first picture, but it's a lot slower because it's the second picture, because we got JavaScript again. Okay? So, Flutter is not like any of these. Instead, what Flutter does is it uses native code, native ARM code, to talk directly to its own widgets, every pixel from top to bottom controlled by Flutter. And all that has to do is talk to the canvas and the events. The canvas is actually Skia, if you're familiar with that from Chrome. It's actually that, they use that canvas. And it has to talk through platform channels to get to the services. Totally different layout. And the most important thing again here is you write that green code on the left side once in Flutter. And it works on both platforms. So what makes it unique? It doesn't use WebView. It doesn't use OEM widgets. So there's no penalty going back and forth between all the signals coming in and all the rendering going back out. Skia from Chrome, I said that already. The widgets are all written in Dart with a thin layer of C++ to talk to the native widgets. So you control, in your Dart code, in your Flutter application, you control every single pixel on the screen. You don't like the way a particular slider works, you can make your own. It's that simple. Dart code also handles all the compositing, all the gestures, all the animation, all the frameworks. So you can have those precisely the way you want for your brand first application. The code is easily inspectable, patchable, extendable. You want to know how a particular slider works? You press go see source in the in your API or in your UI or your editor, and it takes you right to the source code. And you go, oh, I kind of like that, but I think I want it to go slower and then faster rather than like that. Well, you could just subclass that and do what you want. It's all fully accessible as source code all the way down to the SKIA level. And the cross-platform look and feel is easily provided, or you can customize it for platform feel. I think I'm going a couple more slides, and I'm going to try to do the demo. Fingers crossed. Okay, so the technology consists of multiple layers. Everything in green above is in Dart. So your foundation classes, your animation, your painting, your gestures, everything. And the only things at the very bottom level in C++ are SKIA and the text engine and the Dart engine. It's not a virtual machine. None of this is VM. This is all just native ARM code compiled down talking to native ARM libraries. So we have on the left-hand side of the screen, I hope I've made it almost big enough. Probably bad for you people in the back. Let's see if I can do that, I think. Can most of you see it? People that want to see it, move forward, I guess. Right. All right. So this is the Visual Studio Code IDE. And yes, for all of you who know me as an Emacs guy, yes, this finally got me away from Emacs. Because there's so many cool things this does for me as I'm trying to do autocomplete on classes or look things up or whatever. So yeah, it's really, really nice. However, I have added the Emacs key bindings. So I can still move around in this thing, right? So I have the Emacs key bindings. So not much to say about this thing, but there's not a lot of code to this. But this code, when compiled, creates this app over here. And I have saved you the 30 seconds it takes to actually fire that up. But what I want to point out about the 30 seconds that I saved you, so you wouldn't have to see it fire up, is that's the normal development cycle for most people. If you're not using Flutter, you don't get the thing I'm about to show you. Okay? And the thing I'm about to show you, well, first let me tell you what this app does. It's not a really brilliant app, but it is the app that when you say Flutter, create a project, this is the first app it gives you. Because it's kind of a nice starting point, so we got that there. Okay, all this app does, you push plus down here. Can you see me pushing plus? A little bit, okay. You push plus down here, and it increments a counter. Woo! Okay, that's pretty exciting, right? And it was only, how many lines of code? How many lines of code, right? 63 lines of code, not counting a couple empty ones. Now, for the cool part. I don't like blue. I want it to be orange. Except I have to spell it right, don't I? I have to remember where my cursor is. Here we go. But I will say save when I'm saving, and you watch how long it takes to change this over on the right-hand side. Save. Done. I just made a simple structural change to this code, and in less than a second, it automatically refreshed it for me. I'm not done. What's my next thing? Oh yes, change the structure. Okay, so I'm going to go down into here, and you see it says you've pushed the button this many times. I'm not going to make just a color change. I'm actually going to make a structural change. I'm going to rip out this text, and I'm going to put counter is. Now notice this time I didn't just change a color, I actually removed a widget. Here we go again. Save. Done. Imagine developing a mobile app with that kind of cycle time. Okay, next thing is delete the add count as. I just did that. Okay, so short change. Wrap in a column. Okay, so let's, this little FAB down here in the corner, I actually want to put two of them there. So I need to have two buttons right above each other. There, now, the thing I want you to notice is that the button went to the top because it defaults to the top for a column. It defaults to the beginning, actually, for an end. So we have to add, a, let's see, what do they take? It takes main axis alignment. Main axis alignment, already got it there. And main axis alignment end. Okay, save again. and I put it down to the end. Okay, good. Now it's working that part, but I don't know why my refactoring's not working. That's really freaky. Okay, so I'm going to do only a couple more things before it stops working again. So, yes, this is a little crazy. But you saw how quickly I was able to change structure again, and it just changed. So I want to take another FAB and copy it, and that probably means I'm going to have to put a comma in here. I'm going to save it again. Okay, now I've got 2 plus button, because I want to get a minus button. I'm trying to get to a minus button. Okay, well, first let's change the icon on this to remove. Save. Okay, the icon's right, but the operation is still wrong. They both do plus. So we need to go up here and take increment state and copy it and make decrement state, which it'll complain at for a moment because there's 2 subroutines with the same name, 2 methods with the same name. Now it won't complain. It'll just complain that it's not being used. So we go back down in here. We take inc and make it dec. And that's, sorry, what? I need a what?
You need to update the function itself because it's not.
Oh, right. Yes, that's usually a mistake that I make, which is kind of nice. Thank you. See, you guys already know Dart. It's just a matter of, so you guys can start mobile development tomorrow. All right. There we go. Goes down, goes up. But there's one other thing I wanted to show you in that, and go back to the actual slides, because I don't want to do any more demos, because obviously it'll break things, is that when I saved the file, the counter didn't change. State is maintained all the way through the application. So let's say you're in a mobile app, you drill down 5 or 10 pages, you've done a lot of things, and now you see that something should be red instead of blue. You can make it red and hit save, and you're still at that 8th page down. That's game changing. All right, so is the batteries included? Yes. It's optimized for 2D rendering, excellent tech support. It's a reactive style framework. Again, a rich set of widgets for Android and iOS, in particular, the material design widgets, which are really beautiful, and I think better than iOS's widgets, is completely fleshed out. It's a 100% citizen of material. Okay? What's odd about that is that because Flutter is rendering their own widgets, you can actually ship material widgets even before material was thought of, because it'll run all the way back to, I don't know how far back, but it'll run way back there. And so it's going to be even before material came out. There's an API for unit and integration tests. Again, interoperability. There's a headless test runner for Windows, Linux, and Mac. There are command line tools, of course, for building, testing, complying. And as I mentioned a little bit earlier, Pub offers a way to share packages, libraries, things like that. What about editor support? So Google builds plugins for IntelliJ, IDEA, Android Studio, and VS Code. VS Code actually started out as a third-party project, and Google actually hired them for 2 years so that they could keep VS Code up to date with Flutter. Pretty impressive, I should say. Of course, they got money, so it's not like I could do that, right? It's an integrated development experience. I've tried to show you a couple times that I could mouse over things and pick up all the different parameters there and a bunch of other stuff. But unfortunately, the refactoring didn't work. I don't know why the refactoring didn't work. IntelliJ, of course, if you like that, it's good for both the ultimate version and the community version. And there's a command line editor, Flutter tool, on any editor that supports Dart. For example, you can actually edit Dart in Atom, Emacs, Sublime Text, and so on. I already said that. Unfortunately, Apple requires that you use Xcode on a Mac to be able to develop. So that's nothing new if you've been doing Apple development before, is that they require their tools. Of course, with Android, you can do Android Studio, which is any one of the platforms. Flutter tool, or the plugins, of course, invoke the compilers directly, so you don't need to know much of anything about all that stuff. And no need to learn the vendor tools except for deployment. I don't know anything about Xcode, and I built that app you just saw. I have 3 apps on my phone already that I'm experimenting with that I haven't known anything about Xcode for. It just works. So the framework, yes, I'll admit, especially in this conference, that the framework was inspired a bit by React and React Native, but it's also designed to be layered and customizable. Of those green layers I showed you before, you can replace any piece of that. None of it is essential. As long as you meet the APIs up and down, you can replace it with whatever new behaviors you want or whatever new looks you want. And you can create widgets from scratch. The widget layout is very quick because it's single pass. That's part of the lesson they learned from Chrome, is you can't go up and down 10 layers, to try to figure out a layout for something, right? So, in fact, the whole reason Flutter exists is because the mobile people wanted something that wasn't like just WEBVIEWS, because WEBVIEWS were really, really slow. They started with an experiment to see if they could take all the non-essential parts of Chrome needed for layout and use that as a web view, and that still wasn't fast enough. So they said, let's start over. And the Dart team was already building Dart for server-side stuff, so the Flutter team took it as their client-side stuff. APIs, yes. And there's test coverage publicly available for every commit. So how does it run? So on the Android, the C++ code is compiled with Android's NDK. The iOS is compiled with LLVM. Dart is AOT compiled, ahead of time compiled, to native code for deployment, which means it's extremely fast. It gets tree shaken, so you're not using any parts of libraries that you haven't actually accessed. It's very, very quick, very quick. However, that would be too slow to do the demo I just saw you, because that would take 30 seconds every time around. So they use a jitter just for fast reload during development. So that's why it's so quick. There's a full VM actually sitting on the phone while I'm doing this demo. You can't ship code to at least the Apple Store, I think also the Android Store, when it has that sort of thing in it though. They don't want jitters out there. They don't want complete VMs out there. So that's why the AOT is there as well, also because it's faster. So there's no interpreter or VM involved. Even the JVM, there's no JVM. It's not being used at all, right? So faster than some Android apps. And the OEM widgets by default aren't used. Well, actually, it's never used. All the widgets are native Dart code. There's, again, higher performance, better binding to Dart code, better cross-platform. It's all open source. It's all patchable, subclassable, understandable, inspirational. And a consistent behavior on all platforms. One of the things that was key to the Hamilton people was we need to have the exact same look and feel on both platforms. So if you can give us that, we're on. We're ready. We're going to do it. And again, ships material design to phones even before material came out. Why did Flutter choose Dart? Why did one Google team choose another Google team's thing? I don't know. But the Google mobile team wanted numerous criterion. One was it had to have a JIT-based cycle for quick development, as I showed you in the demo. But it also had to be AOT for efficient ARM code, and also because that's the only way the stores will let you get on, is to have actual ARM code there. You can reuse code in pub. That's kind of fun. With Dart as Flutter's language, you can reuse code in pub. So pub was originally set up for Dart, but then Flutter came along and said, hey, we can use some of that stuff. We can use those math libraries. We could use this and that. So they get to share their development that way. The Flutter team, of course, has influenced Dart development. Dart didn't originally have an AOT compiler, so that's all new. And Dart, Flutter said, we need a VM that's optimized for best latency, or rather least latency, I should say, rather than throughput. So the original Dart VM was all about throughput. Now it's also about, when the right switches get flipped, it's about making sure that your latency is as low as possible so you get a responsive mobile app. Also, Dart is strong. In other words, you can't assign an int to a floating point number. It doesn't work that way, right? And as we saw, hot reload, again, sub-second reload times on a device or emulator. It's stateful. You saw how that counter didn't actually change every time I updated some structural thing even. It just stays. Quick iteration, even deep inside your app. And it works by injected source code into the Dart VM, the one that's set up for jitting. You can even add new classes, methods, and fields to that. As you saw, I added that method, and it still just worked. So it works anyway, no matter how that works. You can't reload global initializers or static field initializers, but that's not bad. If you have one of those and you get a complaint from the reloading system, you press one more keystroke and it actually reloads or rebuilds and reloads the whole program. So it's not bad. Actually, it doesn't rebuild it. It just simply injects more JIT stuff into there and then restarts the program, which can take a couple seconds, and you lose your stateful variables. That's all there is to it if you're adding extra structure like that. Okay? Thank you. Thank you very much. All right. And if you change the main method of the app, the main method is sort of where they put their hooks in to actually do the jitting, so you can't change the main method because they'll never see that. And again, for these, the hot restart is needed, but that's very fast too. So a half a second typically for the hot reload, and about 1.5, 2 seconds for the hot restart. So it requires at least Jelly Bean, iOS 8, and it has to be a 64-bit device for now. They are talking about also allowing that on 32-bit devices, but they don't want to put a lot of energy into it if there's not a lot of demand for it. And as you saw, it worked on the live device. It worked on, if I had my phone attached, you could actually see my phone. Everything you saw on the screen could also be being done on my phone. So it will constantly talk to my phone and download the new pieces. And Google tests on phones, no device compatibility guarantee. Google also doesn't test on tablets, but people have found it works fine with tablets. You have to do some device orientation sensation to kind of figure out, if it's horizontal iPad or a vertical iPad or whatever, right? And it's possible to embed a Flutter view into an existing iOS and Android app, and that is getting better now. And in fact, better documentation coming. It's already pretty up to date now. So if you have an existing iOS app and you just want one page that's Flutter or 2 pages that's Flutter, you can also embed that in your app. Again, desktop web apps, not on the roadmap, although those are being worked on by third parties. And by desktop apps, I don't mean Dart-based desktop apps. I mean Flutter-based desktop apps would actually be both reasonable and just something Google's not committed to. So you get out-of-the-box access. And I'm running behind time, I can already tell. So let me see what's the most important stuff here. I'll just let it all go by. You can extend and customize widgets. Everything's done by composition, which is really cool. Composition is preferred over inheritance. And many material widgets actually have decomposable parts, so you can reuse them in different ways, mix and match. Let's see here. This isn't really all that important once you got the gist of what this is all about. You're able to run parallel. Isolates basically give you the ability to access things in parallel. Also, as of recently, Flutter can run in the background on both iOS and Android, which is really slick. And because the concurrency is done with no shared memory parallelism, there's no locks required. You can't run into a deadlock, which is really nice. There's no markup syntax. You saw the entire code that was running. There's no separate XML file. Thank God. All right. It's all done by composing these Flutter widgets. And so the nice thing about that is that means you can do hot reload, you can do dynamic environment adaptations, and you can refactor the code. You start seeing the same set of things in your code. You can take that out and make it a separate widget. So now you can see that over and over again that way. Whereas if it was XML, it'd be a lot tougher to do. Okay, reuse parts and so on. So the Open Issue Tracker, Stack Overflow is very active. I try to read it every day, and there's like another 10 questions again. There's a mailing list. There's a Gitter channel. And Google people are often answering questions there. It is all open source, very relaxed license. Support for showing licenses directly in the app via widgets. Again, most of the work's being done by Google. So, advantage of reactive views, no JavaScript bridge, fast, smooth, predictable code compiles to AOT to native ARM code. Developer has full control over the widgets and layout. Comes with beautiful customizable widgets, great developer tools, amazing hot reload, more performant, more compatible, more fun. And you can develop for iOS and Android in one code base, but that's not actually the most important thing about it. If you were just building for iOS, this might be interesting. If you were just building for Android, this might be interesting. It isn't about cross-compatibility, cross-platform. Exactly. In short, revolutionary. And I think this is my last slide. Just want to get all the way down to the end of this so I can leave that on the screen. There we go. Thank you very much.